Welcome everyone to our technical session on data interoperability and integration within ArcGIS. I am Adam Martin, and I'm joined by my colleagues Bruce Harold, the ArcGIS Data Interoperability Extension Guru, and Satish Sankaran, who will be moderating the Q&A later. We are all product managers focused on interoperability and initiatives to make the ArcGIS platform more open. We hope this session is going to help you navigate the topics for how data is integrated and used across ArcGIS and help you understand what data sources and types are supported by which products in ArcGIS, as well as provide overviews and pointers to a number of different tools that can be leveraged to support data interoperability. And of course, as I mentioned, we're going to showcase the ArcGIS Data Interoperability Extension, which is a key asset on this journey. First, we hope you're joining us having already had at least an introduction to the ArcGIS system with an understanding of some of the fundamental concepts and components of ArcGIS, as well as some basic data management and storage strategies, which is actually another session offered by colleagues. It's important to note that this system and all these components are designed and built and continue to evolve to be integrated with a variety of business systems. And you can think of ArcGIS as your location business system in and amongst several other business systems like ERPs, CRMs, with product components at each tier of the technology stack, and that can be integrated at each tier of the technology stack, including application level, experiences, service level, interactions, and of course data pipelines. And integrations can target any one of these tiers or several of them, and of course, which approach you take will depend on the target users, the business needs, and their downstream workflows. Unfortunately, there's never an easy answer to how should I integrate with ArcGIS, because you usually get that dreaded "it depends" answer, because they have multiple options. But today we're going to focus more on the options that fall within this data tier, and ultimately how you move data in and out of the ArcGIS ecosystem. We're also going to touch a little bit on some of the services-based integration approaches for syncing and enriching data between systems. Now, conceptually, ArcGIS is designed to integrate data, virtually every type of data format, from tabular to unstructured, real-time, vector, raster, imagery, all making this data available as ready-to-use services, abstracted in the form of layers that can be added to maps across the web. Now, this bringing together of the world's information as geospatial infrastructure is ArcGIS's mission. Now on to the question of how that data is accessed and integrated. And there are a couple of high-level approaches to consider when trying to get data from over here to ArcGIS on the right side, depending on the data type and the source and the situation. Now first, ArcGIS supports direct access and services creation on top of many enterprise databases and systems of record. This is where ArcGIS can natively utilize that source data without moving it and converting it into other data systems. RDBMSs are the most common example of this type that ArcGIS services are built on top of and supported in our clients. The second approach involves copying and managing data in Esri hosted and Esri optimized data stores or file types. And it's worth noting that some use cases would benefit from this conversion to ArcGIS types and many will not, and the first pattern is actually preferred. Because the main goal of integration and operability, in our view, is to leverage as many data types as possible into a spatial context to enable map-based visualization and advanced spatial analytics to answer novel questions within your organization. Diving a little bit deeper into that how question, there are several solutions and patterns that can be leveraged here. And I'm going to walk through from left to right the most easy to use solutions, point and click, off the shelf types of ways of accessing data, over to the right where you have where more resources or specialized skills are required. So First, the ArcGIS products themselves, as I mentioned, natively access a variety of third-party data systems and data stores. The second pattern and solution is extensions and add-ins, both within ArcGIS or within third-party systems that support that no-code exchange of data and access of data across these two different systems. Those are usually specific to a particular third-party system, and these can be Esri managed or partner managed. It's provided through our ArcGIS marketplace. The third extension is still an extension, but a special kind. It's the ArcGIS Interoperability extension that Bruce is going to show us. This is still low code and no code for moving data, accessing data across systems, and converting and transforming data. It's our go-to spatial ETL tool and our Swiss Army knife that isn't restricted to one particular data system or data type. And lastly, we have essentially the world of custom integrations that are primarily Pythonic, leveraging ArcGIS's extensive Python distribution and Python libraries across the stack, as well as the ability to extend applications and servers and leverage other third-party open source libraries and tools to convert data. And throughout the presentation, I'm going to use this key to refer back to these approaches. So take note of that at the top right as we go through. For example, we have the data interoperability extension here highlighted up in the top right. I'm just going to give a quick overview before Bruce dives into our demos and our use cases to show us how it works in action. But again, this is our extract, transformation, and loading Swiss Army knife of a tool that can access dozens of web and cloud services, as well as hundreds of formats, and either bring them in quickly through this sort of direct convert approach within ArcGIS Desktop and ArcGIS Pro, or you can open up the workbench that you see on the screen and configure a custom spatial ETL workflow in this workbench, and then load it into ArcGIS or one of the other dozens of systems of record it can access. So now we can look at how the data interoperability extension, as well as these other patterns, support a variety of use cases. And in this case, we're going to look at 4, 3 of which involve the actual opening and use of data, and the last one being the analytics and enrichment of data on the fly as we're bringing it into or transferring it from one data system to another, or transferring it into ArcGIS. And of course, we're bringing it in. This is all to the downstream goals of doing more intelligent analysis, more advanced analytics, and or using this data in operational use cases, for example, in field mobile applications like field inspections. So let's start with just the simplest perspective, directly using and exploring data in ArcGIS apps and clients. So this is the common scenario where you, as a user, from the user perspective, are looking at different files in a variety of places and in a variety of formats, using your desktop application or web viewer clients for this data exploration. What's going to help me solve my problem, answer my question? First, let's talk about the native support that ArcGIS has for a number of data systems of record and data sources for vector and tabular data. Relational databases and hosted relational databases are, the primary systems of record that ArcGIS can leverage out of the box with ArcGIS Pro and ArcGIS Enterprise servers. And across all the sources listed here, you can read, edit transactionally, or load data back to, analyze, copy the data over, and publish web services on top of to get full functionality within ArcGIS clients. And we're looking forward to Cloud Data Warehouses support coming soon. When we add our extensions for ArcGIS Velocity and GeoEvent server, as well as our GeoAnalytics server, we unlock capabilities to a number of additional systems, including IoT systems and big data systems within those same capabilities. And this list is always growing, and new data sources are being supported each release. You can see some of the newest data source types that we are connecting with, and also the ones that we're working on in future releases. And we're excited about Google BigQuery, which is currently supported in some extensions and in applications like ArcGIS Insights and the Data Interop extension, but we're looking at native support within our core stack in upcoming releases. And now to look at the actual data file types within these data sources, this gives you a sense of, across these different types of data, which data in white can be natively opened and explored in our clients, like desktop and web viewer, and which ones would need some extensions, potentially like a image analyst extension for Pro, for full motion video, or our real-time extensions like Velocity and GeoEvent server to get at some of those web messaging platforms and things that we see here in blue. And then in orange, and we'll see an example of this, using the Data Interop extension to connect with, varieties of JSON flavors that aren't point and click usable in our clients today, and City GML, which is a special flavor of XML that's standardized. Now here we're showing a sampling of extensions that provide some point and click types of functionality to access third-party data stored in third-party systems and processed. We've already talked about ArcGIS Insights and Velocity being able to connect to special data types and data systems. We also have other Esri managed add-ins that connect to SAS and R, as well as bring ArcGIS data into Microsoft applications and products, as well as Autodesk. Then we also have third-party add-ins that bring third-party data and data systems data into ArcGIS, that as well as into other third-party systems that are provided by ArcGIS partners, which you can find out more information at the Esri Marketplace and Partner Portal. Now, for Data Interop extension, Bruce is going to walk us through how we can use the Data Interop to quickly import non-supported file types.
Thank you, Adam, and hello, everybody. As Adam was saying, there are a number of ways to get external data into ArcGIS. I'm going to show you the very simplest way using Data Interoperability extension, namely just getting some foreign data into a memory feature class in my Pro session. Let's say I've got a new electric vehicle. I want to go on a driving tour of Europe, and I want to know where charging stations are. I'm going to start in the Grand Duchy of Luxembourg. So I surfed the European Commission Inspired GeoPortal. I found this data set here. It gives me what I want. I can see it's available as application-specific GML, so definitely a non-native format there. And I can browse other aspects or look at the data in situ in the app here. So I've downloaded the data, and if anyone cares, this is what this GML looks like. So that's my data. How do I get it into my session? Well, over in Pro, and with Data Interop installed, we have the Data Inspector application available to us. I've opened that up, and I can see the data now on a map. If I check on a point here, what attributes it has, I can surf through the available attributes, and there are quite a few, like where it is and what kind of facility it is. So there's my data, but it's kind of hiding here. I could save it out as some other kind of feature class, but let's just get it directly into my Pro session. If you're familiar with Data Interop extension, you'll know about the quick tools that will bring data in or export data from many hundreds of formats in either direction. I could use that directly, but that would bring in and create a file geodatabase. I don't want to commit to that at the moment. I just want to get the data into my map. So I've wrapped that quick tool in a model. I'll show it to you here. So there's quick import. It does make a file geodatabase, which I do not keep. I make it intermediate data. Then I've got a couple of submodels that iterate through the feature classes that are available and tables that are available, and then they will put them into my map. So let's go back to this model here. We'll open it and we'll say, okay, what is the data? It's inspired GML. I know that because that's where I got the data from. There it is on disk. Okay, and I'm going to set up a couple of other little properties here, which I did with a little bit of research and investigation. Set those things up there. I say OK, and I run the model. It's always good to see some live action, so I'll bring up the message stream here. We can see what's happening. And the GML is interpreted by data interop, and I think from memory there are 300 or so features plus one extent feature. There they are, and they'll turn up in my map. Apply some symbology to the data I just brought in, and there it is indeed in my map. If I go to the content pane, I can see that yes, it's in memory. So I haven't had to make a commitment about getting it into any other kind of data store. It's there for direct use in my map. And I can see that in Luxembourg, you can hardly move without bumping into an EV charging station. So that is how to very simply and quickly get any of hundreds of formats of data into your pro session without committing to any kind of transformation or format conversion for the data.
Thanks, Bruce. That's great. Now let's look at a few custom ways that you can convert and pull in data from other external systems. First, we have our Python notebooks distribution, a Python distribution that allows you to connect to libraries that provide access to certain scientific data formats like NOAA's radar, NexRad radar data. We have GDAL that allows for a lot of conversions as well. It can be accessed through Python in Pro and across the stack. In ArcGIS Pro, we also have the SDK for customizing a plugin data source for unsupported data types that you need to recurringly access within Pro in a read-only way for visualization. Then for data that needs to be converted into feature services and accessed in clients that way, there's an open source project called Koop that provides a bridge that converts any API to a GeoJSON and then onto Esri GeoServices, which is the open source version of the feature service, so that it can be accessed for visualization and limited exploration in ArcGIS clients. Now moving on to the next use case. This is common data migration, and in this context we're talking about really the need for a one-time migration to find your data a new home, and this could be in an Esri supported data store that's managed by users, or again, an Esri hosted data store like the ArcGIS data store. This is your basic ETL. Like this is what you would typically use ETL tools to do, to just move data from one system to another. And there's a number of reasons why you might do that. There's some reasons from an ArcGIS capabilities perspective. You want to unlock the rich set of downstream applications, dashboards, mobile apps, etc., and analysis tools that are available through those applications. You may just be needing to move it for other reasons, right? Like that are unrelated to unlocking the location insights that you want. You might be moving from on-premise data systems to the public cloud, or just retiring other systems. And in those cases, those are good opportunities to see how migrating data in a way that optimizes it for location insights should be part of your strategy. And we have a white paper that we'll share that gets you thinking about that. So let's have Bruce come back and just show us what a migration of multiple data sets might look like using our data interoperability extension. Bruce?
Thank you again, Adam, and welcome back, everybody. Now my scenario is that I want to actually migrate data from anywhere at all into ArcGIS data stores. Now here I am at the Seattle Open Data site. If I click on the link to view all the available data, I will find out that there are, let me see, 1,037 data sets. Let's say I want them all. They will not all be spatial, of course. Many will be tabular, and some of them will be apps even, and not something that we could get hold of as a data set. So how do we quickly get hold of all available and useful data and put it into our Pro project or other ArcGIS repository? Let's take a look. And I'm using a spatial ETL tool here I made for the purpose of interrogating the available data sets and making a spreadsheet, well, it's actually a CSV file, of these available data sets. So we'll quickly run that so we can see what we have up for grabs, if you like, from Seattle Open Data. So we have a link URL to the data in a couple of formats there, what the name of the resource is, the data set, its classification of its type, but very importantly, off to the right are the search tags for the data sets. So we want to preserve these search tags coming from the Open Data system as well as obtain the data itself. So let's do that. Now then, I made up another ETL tool that fully migrates the data sources, the data sets, in an automated fashion. So I don't have to click on links and follow them and see what it is and download it and worry about what it is. I just ask for what I want and I ask for everything. So here's the ETL tool that does this download. I'll run it and I'll explain what it's doing as we go along. I'm a bit at the mercy of my home network here while I'm recording this, but what is happening is an HTTP call is being made to get hold of shapefile format data for spatial data sets. And if it's non-spatial, I'm sending myself an email to look into what to do about it. And if it is tabular, and I'm downloading 600 plus CSV files. Now, in fact, I've disabled these ones on the bottom right here because they would take a while. But you can see these shapefiles are passing through the system here. And what I'm doing here is downloading the shapefile to a folder and also pushing it up to ArcGIS Online as a shapefile item. So if I go into my downloads folder, the data as it arrives, and there should be 10 there now, will be there as a zipped shapefile. So that's the data coming through. And additionally, the data is being pushed up to my ArcGIS Online organization or a particular folder in the organization. So what were there? There were 12 arrived out of 60 a few moments ago. If we go and have a look at the shapefile items as they're being populated, we can indeed find out that the tags are preserved as I wanted. So that is, in a nutshell, how to automate a very powerful migration process with a couple of simple tools and a little bit of know-how. So I could have also published and shared the data I'm pushing up to ArcGIS Online. I haven't done for the purposes of this demo. So we can see that we're getting our 60 shapefile items down fairly efficiently. So thank you very much.
Thank you, Bruce, for that powerful demonstration of migrating a large amount of data into ArcGIS in a matter of minutes. Let's move on to a more complex set of use cases where the goal is continuous integration or data synchronization, continuous integration and data delivery, to borrow a phrase from the software world. Now, in this third use case, we're looking at several scenarios where your organization wants to synchronize two data stores or data systems regularly. This could be just a nightly or recurring weekly process that's similar to the data migration process we saw. That's one way. Could be two ways to sync ArcGIS supported enterprise geodatabases as well as other third-party systems. It could also be a near real-time synchronization supported by API messages, or we also want to consider how we integrate sensor data streaming in from cloud IoT platforms and other message streams in ArcGIS. Now, one of the key components required in the world of data pipelining is this application in the middle, really, that facilitates this automated data orchestration. And these apps can take several forms. ArcGIS has a few extensions that are more point and click that provide this middle layer application to support automated movement of data from different data systems. They work really well in certain particular use cases, which we'll get into more in later slides. Some of the other platforms like the ETL platforms are modernizing as well. We, of course, leverage FME inside ArcGIS through the data interoperability extension as our preferred spatial ETL tool that's services oriented. But we can also leverage, organizations' use of non-spatial ETL platforms as long as they are working with Esri supported data systems that we've already talked about. And finally, our RESTful ArcGIS feature service is wrapped in the API for Python. These are two powerful tools that allow organizations to move data, lighter amounts of data back and forth dynamically. This new world of ETL and ELT require services-based workflows, modularity, and dynamism. So let's dive into a few ArcGIS extensions that enable the continuous integration of real-time streaming data as well as the continuous ingestion from IoT cloud platforms. ArcGIS Velocity is the extension for ArcGIS Online. It's our SaaS offering for IoT sensors. And GeoEvent Server, along with GeoAnalytics Server, are ArcGIS Enterprise extensions. Now, both of these products, even though we're going to deep dive on Velocity, both these products support inputs across the major cloud IoT platforms highlighted on the left side, as well as some generic feed streams and technologies like HTTP polling and Kafka messaging queues. And any format listed below can be ingested, and then and in addition, stored data can be combined with streamed data and processed on a regular basis through scheduling and pushed back out to the platforms and technologies on the right hand side. Now for GeoEvent server, there's an extra SDK where users and organizations can write their own connector for those that aren't supported out of the box with GeoEvent or with Velocity. And you can see some examples there of some fleet management sources where connectors have been built and published for use by all of our customers. So now I'm going to let Bruce take us back to ArcGIS Interoperability extension to show how it can handle continuous integration at the dataset level. Bruce?
Thanks again, Adam, and welcome back again, everybody. Now we're going to look at the concept of continuous integration. So I'm going to go here, and we're looking at Vancouver, Canada. And the data we're looking at here is road closure information. And it's symbolized according to if it's red, it's currently closed. If it's blue, it's going to be closed at some point. And if it's black, it's planned for the future. So this is a kind of of data that's reasonably dynamic, and I think the sites where I obtain the data says they may change it even every half hour or so. But let's say that we are interested in obtaining a view of this data daily. So once again, we're looking at an open data portal. Here it is for Vancouver's data. Like you saw on the map, there are 3 data sources: upcoming, under construction, and current ones. So that's there. If I wanted to, I could get hold of the data a couple of ways: export it as I guess shapefile, or look at it with the API. But I'm interested in all of those 3 data sources, and a handy way to obtain those kind of data sources on any schedule I want is either an Atom feed or a GeoRSS feed. And I went with GeoRSS because it contains the geometry. So I'm interested in using this RSS feed and using that to continuously maintain a copy of the data or a view of the data as a feature service. In fact, the feature service I've stood up is in my portal here. I've called it Road Ahead, and that's what you're looking at in the map there. So if we go back to ArcGIS Pro, how are we going to do this and do this on a continuous basis? Let's have a look at the ETL tool I built for the purpose. All I'm doing, and it's a pretty simple workspace, is reading the RSS feed like you saw on the website there. I did a little bit of work to make the date time fields work inside a feature service, and I reprojected the lat long data to Web Mercator. Then I made sure that the geometry that's in the RSS feed is going to be polyline. So in where lines close back on themselves, they can be interpreted as polygons. I changed that. The only last thing I did was rename some attributes to be lowercase, like my portal wants. If I go back to the map, just zoom in a little bit here. We should see some action. I'm going to go run the tool interactively while it's open for editing. And I forget how many road closures are contemplated or in effect in Vancouver today, but we'll soon see. The RSS feed is interrogated. There's 667 road closures being handled, and they get written out to the feature service. In a particular mode, what I'm doing here is I'm truncating before inserting. There's a couple of ways to handle that, but there you go. Let's see now if we refresh the map, if anything new turns up. Oh, I saw some changes. So that's as of today, the road closure situation in Vancouver. Of course, it changes every day of the year. To maintain it, it's very simple. I just run the same tool. I just ran in edit mode, and I simply schedule it. And I'd say run it, let's say daily at a particular time, every day, and never end. I could say set up my schedule like that. Then in the history view in the schedules tab, I'd be able to see what was going on. And so long as my computer remained up, then on a daily basis I would have a feature service available to my whole organization or anywhere in the world that tells me the situation for, say, my logistics purposes.
Thanks, Bruce. That's a great example of a use case where you need just a nightly synchronization of the data. Now let's move to how do we support near real-time synchronization, and this pattern requires custom development and custom middleware using our ArcGIS REST feature service API, along with the webhooks associated with those for hosted feature services, and the Python API. And these are deployed nicely in pairing with a third-party application set like these integration and service platforms like MuleSoft or Informatica or any other integration platform as a service that has real-time access to make web API calls, or a serverless cloud application that can be triggered by a similar webhook or other triggering event and kick off some Python scripts to call our APIs to edit data and move data back and forth. This works really nicely for use cases to support integration of, let's say Salesforce CRM on work orders or 311 calls with ArcGIS field applications where you send people out in the field to look at a pothole and update a status on that work order, which gets synced in real time through these API calls back to the CRM. Now let's move into the more exciting part of data integration and access, which is how we enrich data through analytics while it's en route, either through our ETL processes or our synchronization processes, and what are the ArcGIS tools that support data enrichment and processing while in motion. In terms of the ArcGIS products, point-and-click solutions for doing analysis as data is processed from one spot to another. The go-to interface is Model Builder, which packages and orchestrates thousands of geoprocessing tools for data engineering. And those models and tools can be scheduled with a point and a click, as Bruce showed earlier with his example for continuous integration. We mentioned in the last section about continuous integration that ArcGIS Workflow Manager, which is an extension for ArcGIS Enterprise, also can play that orchestrator application role, and it works well when you want to mix sort of manual tasks for data processing or validation with some routinized services-based processing. Now, we already talked about how Velocity continuously integrates data across cloud, IoT platforms, and other cloud data systems. Now let's talk about the real power of Velocity in its ability to analyze data in real time and across large data stores. And through these spatial analytical processes you see here, ArcGIS Velocity can add attributes and enrich data by joining data, as well as creating new attributes using processes such as the calculate motion statistics, which looks at moving vessel data, for example, and calculates average speeds and dynamic distance to a point or a target, and adds that data back to a data set. Now Bruce is going to show us how to leverage ArcGIS REST APIs, in this case the geocoding API, with data that he's pulled down from a Snowflake instance and wants to now geocode.
Thanks again, Adam, and welcome back, everybody. Now I'm going to look at what I'm calling an analytic integration. That's a value add of data while it's in flight between two systems of record. The standalone table you're looking at now in my pro session is 1 million street addresses in the United States, and I brought it into the table you see there, courtesy of our friend, the Interoperability Connection model that you saw earlier. Now, the value add I'm going to do is to geocode that data against an ArcGIS portal geocode service. I'm looking here at the service endpoint. As you can see, it's working against my portal here. If I say go get the geocode there, I'll come back with all the components of the address plus, of course, the XY. So this is a REST service I'm going to use, or it's actually the companion service which works in bulk rather than, or in batches rather than just a single address, but that's the general idea. We're going to turn street addresses into coordinates. That will let me add value to my data in my business processes. So here we are in Pro. I'm going to edit an ETL tool I built for the purpose here, and I'll firstly walk you through this to show you what it's doing. I opened it for editing earlier. Okay, here's the whole thing, right? So a little bit more of processing than you've seen earlier today, but I'll walk you through it so there's no mystery. Here I am reading Snowflake. I've actually capped the read to 8,000 features so that we don't have to wait for however long it takes to process a million. Then I make what I'm calling a single line. You'll notice that the address data is in multiple fields or multiple attributes to obtain all the address components. I'm going to send it out as just single line, which is a concatenation of a address, city, state, and zip into one line. Then I do some of the necessary underpinnings here of getting the data into the JSON structure that the endpoint requires, the geocoding endpoint. I attach with the little row of processing in the green bookmark down here some of the parameters I used to drive the geocoding, and then I send it into this guy here, which is a multiple concurrent geocode processes. In my case, it's going to be 4 because that's as many as my portal geocode service will stand up, but I have gone as high as 64, and at the current release, that's ArcGIS Pro 2.8. Data interop HTTP calls support parallelization. We'll start it running, then we can see what's happening. So having done the geocode, the data is caught, it's JSON, and we parse the JSON, turn it into rows that we then write out, in my case, to a Parquet file and then to OneDrive. We're watching the data go through. What happens is that each 1,000 rows is made up into a batch of 1,000. Capped the whole system, the whole process to run only 8 batches or 8,000 rows, sending in 4,000 at a time in 2 queues. So I'm implementing a bit of queuing theory there to make sure that the server is fully loaded at all times. Now the log file will be telling us how things are going there. So it should be a total of 8 batches of 1,000, and then the data gets sent through to a Parquet file. So here's the Parquet file here being made. And I'm additionally sending the Parquet file out to OneDrive, which I'll put here. So if I refresh there, so it's a few seconds ago, my Parquet file was laid down and sent up to OneDrive. So that's me mimicking the experience of sending it up to some cloud platform or big data platform as a Parquet file. So what did Pro and Data Interop do? And we will look at Parquet, the Parquet file made, Apache Parquet. Now Parquet is not a spatial format, but Data Interop will recognize columns in the data which are spatial in nature. So I happen to know that the X and Y returned by geocoding is WGS84. We will run the tool so that it brings in the Parquet file and it should light up on the map. So this is the experience I'm wanting to describe, in that certain rows are geocoded. That's the value add to my data. I did it by HTTP call while the data was in flight, so it didn't touch the ground on the way through, and it comes through as point data in my map. So that's what I sent up to my cloud storage or my big data repository. So thank you very much.
Thanks, Bruce, for that great example of just adding value to data. Now, in your own work, you might want to hit any kind of REST API, both ones that are hosted by Esri and made available through our location services and our PaaS offering, our platform as a service offering, or Esri services that you customize and manage yourself. Bruce showed you a geocoder that was localized and customized to his purposes. Organizations can similarly do that. Or it could be a completely third-party API. You can have at it and process data and add value in a variety of ways on the fly. So thank you so much for letting us walk you through these 4 use cases for data interoperability and integration, and a number of ArcGIS products and tools that are going to help you leverage location across your data sources to help you gain insight, locational insight, perform advanced analytics, and operationalize your data in and across the ArcGIS system. We hope you'll connect with us. We thank you so much for joining us, and we'd love to continue the conversation with you. So please schedule a meeting with us in the chat below. And you can also connect with us on the Esri community, clicking this short URL to get a link to the presentation and additional links to other resources that are in the presentation.